Right, there are generally about 4 different ways that we calculate slope. Now this was the foldable that we did, and on the front of it, it had how to find all of these. But we usually find slope. We find slope from a graph or from an equation. Those are the easy ones. From a table, we use delta y over delta x, and from 2 points, we use the slope formula, which is on your formula chart. So let's go on through and let's start by, we're going to look at the easy ones first. We're going to do the tables. Actually, let's look at this one first, at the equations, okay? So when I see y equals 5, I'm imagining I have a table with all of my y's the same. Doesn't matter what my x's are. That means I have a number, I have no rise, but I have run. That means my slope is 0. This is one I just kind of have to look at to see. But also, here's the other thing I know. Y equals -5. Can I put that in my calculator? If I can, then I've got slope that is, I don't have undefined slope. Y equals, I have a Y equal button. Remember, this calculator is a function machine. This calculator, all I can do with it is put in functions. I can't put in things that are, I can't put in x equal, I can put in functions though. So when I look at this, if I have this y equals button, again, my calculator is very angry about the battery. I have a y equals button. I can put in y equals -5, and when I look at the graph, I've got a horizontal line. Horizontal line means I've got 0 slope. Okay? Now, when I look at this one, I always look at the coefficient of x. That means my slope equals -5/4. Same here, I look at the coefficient of x. My slope equals 6. Okay, so those are the easy ones, the really easy ones. Now let's look over here. When I look at a graph, I'm always going to write down rise over run. Yes, I know I wrote rise over run. I'm too lazy to write rise over run, but rise over run gets it done for me. So what I'm going to do is I'm going to pick 2 points. Now, when I first did this, I made the mistake of looking, and I'm going to zoom real quick. I made the mistake of thinking that 10 was my x-intercept, but when you look really closely here, you see that it doesn't quite hit there. So I'm going to have to find another pattern. So I see my y-intercept here, okay, and then I see this point here, and these 2 points kind of look like they might be on whole number coordinates. So I don't just assume that I'm right. When I'm looking at rise over run on a graph, I actually plot as many points as I can to try to make sure that every time I plot that slope, I stay on the line. If I'm wrong, eventually I'll start to be making another line, and it'll kind of like go off in another direction, won't be a perfect line. So when I look at this one, my rise is down 2. My run is 3. So I'm going to go down 2 over 3, down 2 over 3, and I'm on the line. Down 2 over 3, I'm on the line. Down 2 over 3, and I'm still on the line. So I feel pretty good about this one. My slope is -2/3. Okay, we're not going to worry about finding the y-intercept just yet. We're going to do that in a couple of days. You know, well, we've already done that, but you know, we'll do that in a later lesson. But right now, we're just focusing on finding slope. Okay, so now let's look at this one. Whoa, what do we have going on here? Okay, now here I've got vertical. I have a vertical line. Okay, which means I have undefined slope. Okay, so for this one, my slope is undefined because I have a vertical line. So anytime I fail the vertical line test, boom, I have undefined slope. That is not a function. Okay, now when I look at this one, again, I'm going to do the same thing as last time. I'm going to find what I think are 2 points. I think those 2 points are on the line. They look like whole number coordinates. So I think that I'm rising 1, 2, 3, and running 1. So I'm going to keep on doing that as many times as I can to make sure that I stay on my line. So I'm going to rise 3, run 1. Rise 3, run 1. Rise 3, run 1. And those lines are all exactly on my graph, so I feel really good about that. Now, when my slope is 3 over 1 like this, even though a lot of times I tell you guys it's okay to leave your slope as a fraction or an improper fraction, when it's over 1, we just write it as the whole number. We don't write it as a fraction. Okay, so that's how we find slope from graphs. Now let's look at tables. Tables are like old school 7th grade rate of change. Last year y'all call it was delta y right here, delta y over delta x, y'all called it rate of change last year, ROC. Okay, so we're just going to find our rate of change. So we're going to find the change in y. Oopsie. Yeah, okay. Minus 6, minus 9, plus 8, plus 8, plus 12. Now, I'm telling you that these are actual linear equations. If they were asking you, does this table represent a linear function? Then I'm sorry for the beeping.
Quan, Sam, come to the front, please. Quan and Nicholas.
Ooh,
Win.
they better get to the office.
Nicholas
Yep.
Win.
Okay. So as I was saying before I was rudely interrupted, I have two different numbers. Now, if I was saying, does this table represent a linear function, then you would have to do delta y over delta x for every row in the table to confirm that they were all the same. Because if they're not all the same, then you don't have a linear equation. But I'm telling you that these are all linear, so we're just going to test one row because we don't have all day. So we're going to take our delta y over delta x. This one is negative 6 over positive 8. That reduces to negative 3/4. Now again, I like to leave my slope as a fraction, but if you put negative 0.75, it's not wrong. I just like to leave it as a fraction because anytime I'm dealing with slope, there's a chance they're going to ask me to graph it, and it is easier to graph a rise of negative 3 over a run of 4 than it is to go down 0.75 over 1. It's just easier to graph, so that's why I leave it like that. But this is not a wrong answer. I just tend to leave my answers like that. Okay? Let's take a look at this second one. Second one, we have our delta y is 0 on all of these. My delta x in this case is plus 6, plus 5, plus 2. Like I said, I'm telling you that these are linear. But also, if you see 0 over all these things, 0 divided by 6 or 5 or 2 works out to be 0. So I don't like circling the 0. It makes me feel weird. I usually write 0 slope or m equals 0. Okay, they're both the same thing, but for some reason writing a 0 and circling it just looks like a donut, and I don't like it. All right, now let's look at the last one here. Okay, so for this one, we're going to add 4, add 5, add 2. I'm going to add 4, add 5, add 2, and my delta y over delta x is 4 over 4, which is 1. So my slope is 1.